This is my extra credit video for Biology 2010C. Today in my video I will be discussing Hardy-Weinberg problems. When dealing with Hardy-Weinberg problems, there are two formulas that need to be known. And the first formula is for alleles, which states P plus Q equals 1, where P is the dominant allele and Q is the recessive allele. The second formula is the genotypes formula, where it is P squared plus 2P times Q plus Q squared equals 1, whereas P squared represents the homozygous dominant, and 2P times Q equals the heterozygous, and Q squared equals the homozygous recessive. Here's our first problem. Our first problem reads, there are 100 students in a class. 96 did well in the course, whereas 4 blew it off totally and received the grade of an F. In the highly unlikely event that these traits are genetic rather than environmental, if these traits involve dominant and recessive alleles, and if their 4% represents the frequency of homozygous recessive, please calculate the frequency of the recessive alleles, the frequency of the dominant alleles, and the frequency of the heterozygous. Okay, I went in and I have highlighted and bolded some key information where there's 100 students and 96 did well, where 4 did poorly. And then I underlined and highlighted that the traits involved are dominant and recessive alleles, and if 4% are represented. Alright, so we're going to do the first step. Okay, this step we're going to do, the first step is the frequency of the recessive allele. As we know from the from our formulas, recessive is represented as Q squared. Homozygous recessive is represented as Q squared. And in the problem we were told that the recessive was 4% or 0.04. So to find Q, we have to take the square root of Q squared. And the square root of 0.04 is 0.02. So therefore, the frequency of the recessive allele is 0.02 or 2%. Alright, part B. The frequency of a dominant allele. Since the recessive allele, which represented as Q, is 0.02, and we know from our formula that P plus Q equals 1, we can set our formula up with knowing that Q is 0.02. So our formula will go P plus 0.02 equals 1. So to find P, we subtract 1 from 0.02, which we get 0.8. So the frequency of the dominant allele is 0.8 or 8%. Alright, so for the heterozygous individual, from the genotype formula, we know that 2 times P times that heterozygous represented as 2P times Q. And in the previous steps, we found P to be 0.08 or 8%, and we found Q to be 0.02 or 2%. So therefore, we just plug these numbers into 2P times Q, which we get. So therefore, we will have 2 times 0.08 times 0.02, which gives us 0.32. So the frequency of the heterozygous individual is 0.32 or 32%. We have one more problem so that we can see if we really got the hang of it. Within a population of butterflies, the color brown is dominant over the color white, and 40% of the butterflies are white. Given the sample information, which is something that will be likely to be on the exam, calculate the following: the percentage of the butterflies in the population that are heterozygous, and the frequency of the homozygous dominant individuals. Like the last problem, I went in and I highlighted some key information. Brown is dominant and white is recessive, and there are 40% of the white butterflies. Knowing the information from the previous problem, we're going to find the percentage of the butterflies that are heterozygous. Since white is recessive, that is represented using the Hardy-Weinberg formula as Q squared. So Q squared is 0.40. So we need to find Q. So therefore we take the square root of 0.40, which is 0.63. So now that we know that Q is 0.63, we have to find P. And since we have one variable from the alleles formula, we will use the allele formula. So to find P, we subtract 1.1 minus 0.63, which gives us 0.37. We're still not finished yet because we have to find heterozygous. And heterozygous is represented as 2 times P times Q. Knowing that Q is 0.63 and P is 0.37, we can plug these into the formula. So now we have another problem, which is 2 times 0.63 times 0.37, which gives us 0.47. The percentage of the butterflies that are heterozygous is 0.47 or 47%. Alright, the frequency of the homozygous dominant individuals. From the formula, we know that homozygous dominant is represented as P squared. In the last step, we found P to be 0.37. So now we just simply take that and we square it to find out the homozygous individuals. So now we have P squared equals 0.37 squared, which equals 0.14. So the frequency of the homozygous dominant individuals is 0.14 or 14%. Thank you for watching my video. I hope you understand Hardy-Weinberg problems a little bit more. And this is my video. Have a good day.